All right, we've got a good amount of people who've joined already, so I'll go ahead and welcome everybody. If I haven't met you in person yet, my name's Joe. I'm the manager of the Aquaculture Information Exchange and excited to bring you today's Connect and Learn session, which is our sort of regular uh, interactive webinar series that we've been hosting. And for today's session, we have Tyler Buckingham. He is with Blue Robotics, and he's going to be talking about their work with the Ocean Rainforest Kelp Farm. And this work is part of the Grow Line initiative, which is all about developing technologies and materials to support regenerative aquaculture. And just before I hand it over to Tyler, I wanted to drop the discussion forum over in the chat. And that is where, after the session, if you have any more questions that you want to ask Tyler about this work, you'll be able to do that there. And hopefully we'll be able to continue the conversation on the website. But with that, Tyler, I'll hand it over to you.
Thank you, Joe. It's really awesome to be able to present to you today. And I have spent the past about 7 years working in the ocean and coastal space. And there aren't very many places out there like the Aquaculture Information Exchange where people from all different spaces can come together and share information and share what they're working on in a productive way. So thank you so much, Joe, for building this thing and organizing it and keeping it running. And thank you all for being here today. As Joe said, I'm Tyler Buckingham. I am with the robotics company, Blue Robotics. We make ocean technology that is low cost and modular and easy to use. And it's really kind of changing the game in the lowest rung of the ladder in marine technology, getting people into marine technology for the first time that have never messed with it, so to speak. My background is that I was an ocean podcaster, and I went around talking with people from really all sorts of different ocean and coastal walks of life, different professions, be it coastal engineering or tourism, hospitality, city managers, port managers. And of course, I talked to a lot of fishermen. I talked to several aquaculturalists and kind of fell in love. I did fall in love. I did several shows on the Ventura Shellfish Enterprise Project, where I live in Ventura County, California. I'm kind of obsessed with particularly regenerative aquaculture. There's so much going for it. So it's a real treat to be able to work in this subject now with Blue Robotics, where we're bringing cutting edge technology into the ocean space. And that really brings me into today's presentation. I'm going to be talking about our work on within the regenerative aquaculture space, specifically within kelp farming. That's where we're starting. We're our ground zero, our first rung of the ladder when it comes to working in aquaculture is going to be on the kelp farm. And that's what the Grow Line initiative is all about. A little bit about Blue Robotics. Blue Robotics is turning 10 years old next month. So we're not a baby, but we're also not Boeing. we're somewhere, we're a growing new ocean technology company. And I think the important things to remember here is that technology in all of our lives, everywhere, not just in the marine space, just everywhere, is getting smaller, less expensive, and more capable. And the marine space presents some really interesting challenges. You're dealing with salt water, you're dealing with pressure, you're dealing with all sorts of limitations of being in a marine environment. But we can apply some of those same technological trends into the space. And effectively what we have managed to do at Blue Robotics is build what I like to call the Legos of the marine technology space, the components. We got started 10 years ago making thrusters. And that was a Kickstarter project, by the way. Very cool story. And since then, we have built enough components where you can see that ROV there with the jellyfish. That's the Blue ROV2. Every component on there is a Blue Robotics component. We make everything on that, including, you'll notice that cylindrical device on the top. That's a a sonar device that I'll get into a little later in the presentation. And next to it on this slide, you see our Blue Boat, which is a 1.2 meter long autonomous surface vessel. And it can be used for, it's a little pickup truck that you can attach all sorts of sensors and sonars and other tools onto to help you farm and do all sorts of other things that aren't, of course, aquaculture related. But you'll also see our big team photo here, our family photo of the company. We're about 55 folks. We're headquartered in Torrance, California, and you'll notice we're like a bunch of millennial folks. So we're really into sustainability. We see a bright future. We see marine technology and the ocean space as a rising road, and we are always looking for positive stories within our space, which brings me to Kelp. I mean, folks, is there a more optimistic and cool story? I mean, aquaculture generally is rad. I mean, the potential to be more sustainable on the planet, to recognize the fact that we live on a blue planet, first of all. These are tremendous steps forward that bring great optimism. And kelp within that is like the crown jewel, in my opinion. I mean, there is just so much going for kelp. But first and foremost, you know, it is a keystone species. If you've ever had the opportunity to dive in or explore a kelp, a natural kelp environment, it's amazing how much biomass lives there. The habitat, the ecosystem of a kelp forest is an amazing feature on the planet, which of course has been degraded, sadly, by anthropogenic activity. But hey, what if we could bring some of that back and produce those ecosystem services in a way that we could also produce food and potentially even combat climate change. So that's, like, in my opinion, a triple whammy win. That's an incredible, let's call it a grand slam home run. Kelp is an amazing story. And that is precisely the sort of stuff that we want to be involved with at Blue Robotics. We want to get involved. How do we get involved in the kelp story? We're not kelp farmers, as much as maybe I would like to be one. We need to go and find a way to get involved. And of course, what do? Well, we're going to bring to the table what we do best, and that's the technology side. But we need a partner. And so the next step in our quest to become involved in this great story of kelp in this moment of time that we're in is to partner with real kelp farmers and folks who really know what they're doing, experts in the field. And fortunately, just up the road from us in Santa Barbara, California, are just these folks. These are the Ocean Rainforest kelp farmers. Now, Ocean Rainforest is actually a company based out of the Faroe Islands over in Europe, across the pond. But this particular Santa Barbara project was funded by the Mariner program under the Department of Energy's ARPA-E program. So this is a test bed pilot project kelp farm. It is actually the only kelp farm currently operating in federal waters. I think it's the only kelp farm to ever have operated in federal waters in the United States of America. And it's 86 acres, which is quite large. You know, your average size farm in, for example, Maine might be between 4 and 8 acres. So we're talking orders of magnitude larger than kind of the standard farm that we see today. They're growing giant kelp, which is our native kelp. And it's, as I mentioned, they are learning how to do this as we speak. This is a learning project. And so it made a lot of sense for us to partner with them and learn what kelp farming was like from their perspective. And there's just only one way to do that. I mean, I wish that this could be done on a desk, but you can't do that. You actually have to go out onto the farm. You have to spend time on the water. You got to get wet and get seasick, I will also add, because I don't know if you can see here in this photograph, this is the surface of the Ocean Rainforest kelp farm. And you can see those big yellow buoys there. Those are at each end of the horizontal lines that then the grow lines hang off of, and you can see those orange buoys there in the middle, and those kind of mark those horizontal lines. So we went out to the kelp farm and started just going through activities. I mean, we had 3 missions, and we failed all 3 of them. I mean, it turns out kelp farming is hard, and using technology on the kelp farm ain't easy either. These are real ocean conditions. The visibility about every time we've been there, we've experienced some good visibility, but most of the time the visibility is suboptimal. Most of the time the currents are variable. Maybe it starts off calm, but within an hour, the currents are ripping. So there's just a bunch of information that we learned about what it is to kelp farm on the water, but we came away with some really important key insights. And most importantly, it's that kelp farmers want to know what's going on in the farm at all times. You know, if you're a terrestrial farmer, you can imagine how insightful it would be for you to walk your fields and look at your crop, lay hands on your crop, see look at the leaves, see how healthy your crop is. And kelp farming is exactly the same way, but just way harder, because all of those grow lines are 30 feet under the surface. And needless to say, you can't assess the health of the kelp from the surface. And if you wish to bring that grow line up to the surface, say to your boat, you can do that. It's time consuming, and it's disruptive to kelp, which tends to be fairly fragile. You might lose some of your crop doing that. So non-invasive ways to go down and check out your kelp. And of course, these are ROV activities, right? Like, what we can do is we can you see this picture of me here on the boat. What we're doing there is we're deploying an ROV to go down under the water, 30 feet down, and inspect. In this case, we're inspecting the brackets that hold the different lines, the lines of the farm, the actual structural aspect of the farm together. And that is actually a part of their permit with the Army Corps of Engineers and the California Coastal Commission, that they have to inspect those brackets monthly. And you can imagine the cost. At every one of those big yellow buoys in this photograph is a bracket. So you can imagine having to take divers and do that task over and over and over and over again, how long that would take and how expensive that would be. This has got to be done using modern technology, particularly if we're going to expect kelp to scale up and for this to be kind of a larger scale activity. The other thing that we learned in this activity is that data is super important. What you're going to be doing on the farm is studying it. You want to know what's going on at all times. So of course, visual inspection, being able to look at your crop is very important. Being able to look at your gear. How fouled is that line? How fouled is that bracket? Going down to your bottom gear. This farm is anchored on the bottom with, I believe, 24 anchors. It actually might be 28 anchors. All of that bottom gear could get pulled, dislodged. Being able to go down, lay eyes on it, make sure everything is looking the way it should is extremely useful and important. And should point out that the depth here at this farm is about 270 feet. So getting down there is not feasible with scuba equipment. You're going to need to use some sort of technology if you're going to do this on any sort of, cost-effective basis. So we went out, we spent all this time on the farm. And this, by the way, I should point out that these field days are ongoing. This is something that we will never stop doing. This is how we learn, is by getting out there with these kelp farmers. And our goal internally is to develop the real deal bona fides of what kelp farming is. And that means we have to experience it. We have to know what it's like to be out on the water, what it's like to be doing the job. And I'll just majorly shout out our partners here, Ocean Rainforest, for opening their workflow, being super candid with us about what it is that they're doing, and really allowing us to learn from them has been super important for us. We're going to continue to do that. And we came away from these activities with some fundamental truths that we are now going to be working on the technology side about kelp farming. Firstly, smart farms, kelp farms need to be smart farms as we scale up. And particularly as we move further out to sea. I mean, there's this story happening before our eyes right now. The largest producer of kelp in the world is South Korea. And they've been producing kelp in South Korea for a long time. There's a long institutional, your granddaddy's granddaddy might have been a kelp farmer. And the way that they grow kelp in South Korea is historically not much different than you would see long lines, but it's all inshore, very, very close to shore, which of course makes it easier to do it. It's you don't have to go farther out to sea. Your lines are right there. It's easier to build your farm, all that stuff. It's easier closer to shore. Well, with climate change and increasing sea surface temperatures, they're no longer able to grow that close to shore. So they've been forced to move further out to sea. And I mean, this demonstrates, I think, several things. But one of the things is, as we move further out to sea, the costs go up. You've got to find efficiencies wherever you can. And secondly, as conditions change, you need to measure them. You need to understand what's going on, the minutia of what's going on. This is ocean science that we're talking about here. Kelp farming has to be science-driven, science-based. Sorry about that. That's the dog. Hold on one second. So data. How are we going to get our data on the ocean farm? The answer is we are going to need to deploy sensors on the ocean farm. That's going to be cameras. That's going to be CTDs. That's going to be other environmental sensors that are going to measure water quality, different minerality, all sorts of stuff, nutrient load in the water. These are the sorts of things that kelp farmers want to know. We're also going to use sonars. I mentioned visibility isn't always great, and it's not always necessary for you to see what's going on. Sometimes you need to navigate from place to place. Sometimes you're just trying to follow a line down the water, and utilizing sonars are incredibly useful. Basically, any kelp farm that's going to be built anywhere, before it can be built, needs to be there needs to be a benthic survey before that can occur, and part of that would be scanning the seabed with sonar, with side scan, to know what's down there, and then of course using probably ROVs to do a broader assessment. But you can see the role of sonars everywhere. I'll also say that on the Ocean Rainforest kelp farm, that we have a partner out there based at UCSB who is utilizing a Blue Boat autonomous surface vessel. I'll talk more about that in a second, with side scan sonar on it to measure the biomass of the kelp. So this is yet another way to monitor your crop non-invasively from the surface, getting real-time data back, and that would help drive decisions of like when to harvest or when to seed, important decision making. So we're going to need to deploy this technology onto the farm. It's inevitable. We got to do it. We have to get this stuff out there. The question is how. And it's just going to be the truth that probably the lowest barrier to entry of technology out there to deploy technology is going to be taking a buoy. You saw the picture of the farm. There's buoys everywhere. Making buoys smart. Smart buoys are incredibly useful. Here we have one made by iSensus. There's lots of smart buoys out there on the market. You'll notice some features on this bad boy. It's solar powered, so it can be deployed for long periods of time. You'll also notice some other Blue Robotics components. I want to point out that enclosure, that's a pressure relief valve, I believe, and a penetrator. We make a lot of those little components that are in this buoy that is not our product. And that's just an example of how Blue Robotics kind of plays in the technology ecosystem more broadly. But smart buoys are really important, I think, across the board in ocean science, but certainly in ocean farming. Being able to know the conditions out at the farm, being able to transmit and communicate that information, back to shore, and be able to have real-time ocean data is absolutely essential for kelp farming in the future. So we got to talk about smart buoys. We've also got to talk about ROVs. Now I've already mentioned and pointed out some ROVs. Here you have our Blue ROV2. This one has a cinematic camera mounted on it for really high quality imagery. But the point is that this device here is like it's like a little tractor. It's an under tractor, and you rig it up just with any other. You rig this up for the task at hand. And we've already been really piloting all sorts of ROV activities out at the Ocean Rainforest farm. And I can just say that, like, operating an ROV in a kelp farm is there's the technology, and then there's the technique, because you're dealing with lines everywhere. And so how do you operate effectively without becoming entangled? How do you operate effectively through the real ocean conditions of changing currents and changing visibility? All are challenges, but we're developing some interesting techniques. Like, for example, and I don't have a picture of this on hand, but we've 3D printed like what I would describe as a shepherd's hook that you can use to traverse vertical lines. So say you want to go down the 270 feet down to a bottom anchor. There is a vertical line that you could follow to get there. Well, if you're going to follow that line down, you are going to, at some point, perhaps find really tough visibility and really tough currents. And it could be extremely challenging to make out that vertical line in those conditions, particularly in the dark. What you can do to help with that is put that hook on the line, and that hook will basically keep you connected to the line the whole way down. So you don't have to visually navigate, and you can kind of just descend. We're developing little tools like that and techniques like that to help farmers go through the business of getting down there without struggling too hard to lose the line and spend battery and time going up and down and trying over and over again while the boat, while you're trying to do this on a pitching boat on the surface. It's very challenging. Yes, I already mentioned the idea of walking the field as a farmer with an RV, with this camera system. You can fly right next to your kelp farm and see the health of the kelp. You can visually see it, which is outstanding. And of course, you can mount all sorts of sensors and water quality sampling. You can do all sorts of science activities with this ROV as well. Point is, it's modifiable. It's like your tractor. It's like your John Deere tractor that you put, a disc plow on the back of, and then maybe you take that off and you put a backhoe attachment on or whatever. Like, it's modular. You customize for the farm activity that you're doing. Finally, next, I'm going to talk about autonomous surface vessels. This is our blue boat here pictured. Autonomous surface vessels are, you can imagine on a 4-acre farm, fairly small farming situation, how it would be challenging in a boat to get around and see the whole farm. It's a lot of space, actually. Well, you got to automate that. You got to use technology to make that a more manageable activity. And autonomous surface vessels are a tremendous way to do that. There's all sorts of things that you could do. It's also like a tractor, right? It's totally modular. You can do all sorts of customizing to it. I already mentioned that you can put side scan sonars on these things and monitor your crop, your biomass. You can also do autonomous patrol. One of the issues that they're having at Ocean Rainforest are, like, folks driving their boats straight through the farm and perhaps dragging gear, and they need to know what boat that is. And one of the ways that you could potentially deter folks from doing that is to have an autonomous little security guard out there with a camera on it, putting around, keeping an eye on things. You can imagine this is important for environmental monitoring as well. You can attach, I haven't mentioned acoustic monitoring yet. That can kind of that goes in the sensor category, but hydrophones and acoustic monitoring are definitely going to be essential in kelp farm management into the future, particularly as we think about entanglement issues and, environmental permitting. These types of technologies, autonomous surface vessels, can also help monitor that sort of activities as well. Scalable, like This boat is $5,000, $4,000. Like this is not an incredibly expensive tool that you could never afford. If you're a farmer, this is something that could be in the budget, could save you a lot of fuel, could save you a lot of time. You go out there, you send this thing on a mission. It's mowing the lawn, monitoring your kelp growth while you're moored up, engine off, kind of observing it. So you can see how this is, and you can operate multiple boats at the same time to save time. So you see how this kind of scales up, allows for scaling up of the farm activity. Of course, we can't talk about all of this technology without acknowledging the fact that it's got to be the human who operates it, right? Like ultimately it's about that kelp farmer's hand being able to hold the technology and have confidence in it. And when you're talking about hardware and humans, there's got to be some software in the middle, right? We need to make sure that we can connect all of this technology to the human in a way that is easy to use. And that's where Blue OS comes in. This is an operating system for robots that we have made at Blue Robotics. I like to think of it as your digital farmhand. This would allow you to control all of your farming robots. So if you have a suite, maybe some smart buoys, maybe an ROV or two, maybe an autonomous surface vessel or two, all of these things can be controlled under a singular Blue OS. And Blue OS is also great because it's customizable. So as we work with more kelp farmers, we will develop kelp farming applications. We call them extensions. And these extensions are going to be software like tools that you can use on your various robots specific to activities that you might do on the farm. Like you might have a vertical line following program, like for example, or you might have a smart buoy data readout dashboard for kelp farming. These are the sorts of things that can all live under Blue OS. It would be a standard operating system for all of these different robots, and it's fully open source. It's fully available to be modified. And really completes the picture. That's what allows the farmer to use all this stuff, is an easy to use operating system that is the same for everything. You don't have to be a roboticist to use an ROV on the farm. I can guarantee that. And where we find gaps, the purpose of Growline is to bridge those gaps. It's not to convince farmers to use a Blue Robotics technology at all. It's for us to learn as a professional community what sort of technologies can work on the kelp farm. And we at Blue Robotics want to be like bona fide honest about what that is. And the truth is that we have room to grow, and we are stoked to do it. We're stoked to grow. It's why we are engaged in this initiative. We're also engaged in several other initiatives that aim to do a similar thing, which is to meet an audience where they're at. So our work continues. We are going to continue to be out on the farm, learning, developing, designing new systems to work on kelp farming settings and aquaculture settings. We will also be talking more about our findings at some upcoming events. We've got the California Seaweed Festival coming up. We've got the Seagriculture coming up in Ketchikan, Alaska. I hope if y'all are coming to any of these things, please find me. I'll be at all these events, and I would love to meet you and talk to you there in person. We're going to have a little happy hour event at both of these events. We'll have some beers and stuff, so we can let our hair down in honor of Joe and have a beer and talk aquaculture. I'd love to do it. And finally, going forward, we're going to keep this work up. We have a lot to learn still. We have a lot of room for growth still, but we're stoked to kind of get off on this foot. We're going to build new partnerships. You know, there's kelp farming in Maine is different than kelp farming in Alaska, and we look forward to getting wet wherever they're growing kelp and learning along with the farmers. So with that, I'd be happy to open this up for questions or ideas sharing. We can have conversation.
Awesome. Thanks, Tyler. Yeah, I appreciate the hair shout out. I was sad to have to cut it, but it was a preemptive measure to keep my baby that I'm expecting within the next week from pulling on it. But yeah, so we can open up to questions. I just wanted to very quickly well, yeah, first of all, thanks to Tyler. That was a great presentation, and something that really there's a lot of overlap with our mission at the Aquaculture Information Exchange as far as making technology accessible to everyone involved in the aquaculture community, including farmers. We are working on developing a mobile app along those lines to make the website easier to use for people who are out in the field and can't necessarily be in front of a computer all the time. I did want to share our next Connect and Learn session if y'all want to register for that. It is next week, same time on Wednesday with James Sibley, who is one of the rare aquaculture influencers, and he's going to be talking about his work with that and how he sort of sees how social media is going to play an important role in the future of aquaculture marketing. I also see that Mike Blakely is here, who's been a previous presenter with us, so shout out to him. And then also, I just wanted to drop a quick exit survey for if anybody wants to take it. It's just a few questions, but it helps us improve these sessions. I will drop that in the chat as well. But yes, please, yeah, if you want to raise your hand if you have a question for Tyler, or you can drop the question in the chat, and I can read it to him. But yeah, floor is open. No, we have some seaweed people here. Yes, Beck, go ahead.
Hi, thanks, Joe, and thank you so much, Tyler, for your presentation. It was super interesting. It was great to hear about Blue Robotics. My name's Beck. I'm a blogger in the space. I do a lot of seaweed blogging and just trying to share the story about the magic of kelp. And I was just really surprised when you were talking about how deep the farms are, like 270 feet, I think you mentioned. And I'm just curious, what were they doing before they had access to these kinds of technologies? Like, how were they accessing the farm before they had the robots go down there?
Well, they were using a small ROV at various points. I do believe they use divers in the construction of the farm. But I mean, it's important to note that this Ocean Rainforest farm in Santa Barbara is the only offshore farm. And one of the reasons why offshore farming is, and this farm would not have been possible if it were not for the Department of Energy and this ARPA-E program underwriting, right? So this is definitely an experiment in deep water farming. But the idea is that there is a lot of opportunity in terms of space out there in these areas, and if we can operate in those depths, which there's incredible technology like being developed all over the place. I should share that we have a collaborator, I should say, an integrator also uses a lot of our components up in the Bay Area that is making a robot that sets anchors. So it's like a spinning robot, and it drives in screw anchors at precise locations on the seabed. So you could see how the cost of building a farm, monitoring a farm with these technologies, being able to follow the lines very precisely. I didn't tell the story of our Ping 360. I mentioned that cylindrical, let's see if I can go back and find it. That cylindrical Ping 360 here on the ROV. So one of the things that we still are working on is taking the ROV down, following a vertical line. So we know that there's an anchor down there. We're going to find that anchor. We're going to observe that anchor. But then we want to go to the next anchor over. Well, we know its general heading. We know it's heading, but we can't see it. It's 60 meters away. So what we're going to do is we're going to use this sonar, which is a 360-degree scanning sonar, but we can set the angle to be forward, and we can aim this ROV at it and proceed in that direction until we start picking up that new anchor, and then navigate via our sonar feed into that new anchor. And what that, in theory, will allow us to do is keep the boat up high and the ROV down on the bottom, and move the boat and the ROV at the same time from anchor to anchor to anchor. You can imagine that we're thinking about our tether drag on this. So we're using our new slim tether, which produces way less drag. So there's a lot of innovation that's just going into that. You can imagine just doing that and making that repeatable and easy is kind of our goal here. So the answer is, I don't think that these farms would be feasible at all without low cost, small marine technologies that can be deployed on them.
Yeah, really start like just kind of entering a whole new space and starting all of this. It's a really great research, and just congratulations. It's awesome. So thank you for sharing.
Thank you very much.
Awesome. Who's next? I do know some of you, so I might pick on you if nobody raises their hand.
So Chris Davis had a question in the chat.
Oh, sure. Let's see. Oh, yes. Chris was asking if you can elaborate on assessing kelp biomass with the side scan technology.
A little bit. So, and I'm not going to attempt to recall off the top of my head the researcher's name. I believe his first name is Nick. I'm not going to. I can follow up in more detail, but effectively, this is kind of a similar technology, I believe, to what you're seeing in like shrimp farming and other like more pen aquaculture scenarios, where you use sonar scans to interpolate the amount of biomass that it is returning off of those scans. That's about as most I can tell you. Is like you're going to gather this data based on a scan of the grow lines, and a computer program would algorithmically derive, based on the data of the scan, how much biomass is there. And I believe that the research that Nick is conducting is honing in that algorithm. And I imagine as well the technique to take the scans. And we're really stoked that he's using our vessel, the Blue Boat, as his platform. But you can see, like, the Blue Boat has a computer. All of these, it's interesting, just to back up just two steps that I learned, because I'm not a technical guy really, is one of the things about these modern technologies is there's a computer on all these. Like, that boat has a computer on it. That ROV has a little computer on it. A smart buoy has a little computer on it. And so you got to network those computers and communicate with those computers. But you can imagine the power of having that computer. It's a lot like your little cell phone. It's got a GPS, it's got an accelerometer. So it's collecting a lot of auxiliary data as well, that then you index with your sonar data. And I believe that is like all taken into account in that algorithm of deriving biomass.
Awesome.
I'm just going to read another question here.
Yes.
How do you prevent biofouling on the buoy data recorders? Good question. I don't know. Full disclosure, I have no idea. I'm learning about that more, but long-term, like if you're talking about long-term deployment of any sort of water quality sensor, challenging. I believe that, the ocean, there's coatings, there's wipers. Some sonds have like little wipers that keep the sensor clean. But like permanent long-term deployment is a challenge. It's something that I'm interested in learning more about. And I assume you're referring to the wet parts, the parts that are, you can have biofouling above the water line with birds and whatnot. That is also a consideration. So I don't know the answer to that question, but I'm eager to learn more. Biofouling is definitely a big deal in kelp farming. So in all aspects. So it's going to be an issue with smart buoys as well.
Yeah, I just wanted to add here that, like we really see these sessions as collaborative, and I don't know the answer to that question either, but if anyone else on the session does, feel free to raise your hand, share your opinion. Yeah, we want these sessions to be a conversation, so don't hesitate to share your opinion.
Agreed.
Yeah.
Can I just
yeah, go ahead.
Jump on that too, Joe, because that's actually one of the reasons why we're really stoked on the Aquaculture Information Exchange, is to learn from the community of professionals out there who are dealing with these problems. So yeah, I am by no means, I would appreciate a deeper discussion on that. And I should point out that we have one of our groups here on the Aquaculture Information Exchange is the Aquaculture Technology Group. And these are the kinds of conversations that I would love to see happening in that group. And we could even run some experiments, would be fun. So
sounds awesome. Yeah, I'm going to drop the link to the technology group in the chat if anybody wants to join. We have about 15 more minutes if anybody has any other questions or general comments on the presentation using technology with kelp farming. And someone had messaged me too about where the recording for this will be posted if you came in late. And those are uploaded to our YouTube channel, which we started recently. So I will drop that in the chat as well. It should be uploaded by the end of this week.
Awesome. And yeah, obviously I'm on the Aquaculture Information Exchange as well. If you're interested in keeping this conversation going, if you're interested in partnering, if you have an idea, anything, obviously the exchange is a great place for us to do that. And you can also email me at tyler@bluerobotics.com. I'm happy to communicate that way as well.
Looks like Ethan was saying, he's seen similar products used like mechanical wipers or a biofouling paint, but none of those solutions are perfect.
Yeah.
We did recently have a presentation on birds on gear, sort of what you alluded to, Tyler. And yeah, at every aquaculture conference I've been to, that is a hot topic. So definitely a problem that needs more discussion and better solutions. If nobody else has any other questions, I'll give it one last opportunity, but if not, we can go ahead and close out. Let's see. All righty. Well, yeah, let me drop, in case you do think of a question later, I will drop the discussion thread again in the chat if anybody missed it at the beginning. If you're registered on the exchange, you can reply to that Q&A discussion. And like Tyler said, he is on there. So he will respond to any questions you ask on there. But yeah, thanks again, Tyler. Thanks again to everybody for coming, and have a good rest of your week.
Thank you all very much for coming.
Later.
Bye-bye.